Hey everyone, welcome to another video lesson, and in this lesson you're going to learn how to factor trinomials. Okay, so let's just review what a standard form quadratic looks like. So you have ax squared plus bx plus c. Okay, so this is y equals ax squared plus bx plus c, and we're going to factor today using this method. We're going to find multiples of a times c, so you see the a value and the c value, you multiply them together, and then find the multiples of a times c that when you find them, they add up to the b value. Okay, and then we factor by grouping, which is what we did on the previous lesson. So in this case, we know the value of a is implied to be 1, b is equal to 8, and c is equal to 15. So if I multiply a times c, that is equal to 1 times 15, which is equal to 15. Then I need to find the multiples of 15 that add up to 8, right, which is the b value. So then m for multiples of 15, which is 8 times c, but I need to find the multiples that add to my b value of 8. Okay, so then 15 is 1 times 15, and then 3 times 5, and look no further because 3 times 5 is 15, and 3 plus 5 is 8, so then we're going to use these multiples. So then when we find the multiples that work, then we do factoring by grouping. So what I'm going to do is I'm going to write down x squared, plus I'm going to split up 8x as 3x and 5x. So I'm going to group the 5x with the x squared and then plus 3x plus 15. So notice all I did was I split up the 8x into 5x plus 3x, which when I add them, they give me 8x. But then this is group 1 and this is group 2, so then I'm going to do factor by grouping. So GCF of the first group is x, GCF of the second group is 3. Okay, and that 3 is positive, so I just write the plus in front of it. And then GCF of this group is x, then this becomes x plus 5. And this one here, GCF of this group is 3, and this becomes x plus 5. Now notice we have x plus 5 and x plus 5, so we have a GCF of x plus 5. And then we put together this x plus 3 inside of another parentheses. So these two binomials are the factors of this quadratic in standard form. Right, next example. So for this one, a is 2. So then we need to find multiples of 2 times c, which is negative 4. That's equal to negative 8. Okay, so we need to find the multiples, m for multiples of negative 8, that when we add them, they add to our b value of negative 7. And I think this will be an easy one because this can only be possible with 8 times 1. But notice b is negative, so then the 8 is minus. So then I'm going to do 2x squared minus 8x plus 1x minus 4. So from this group, we have a GCF of 2x, and from this group, a GCF of 1. So then 2x times x minus 4, and this is plus 1 times x minus 4 again. So we have x minus 4 and x minus 4. Let's factor that out as a GCF on the two groups, and then put together 2x plus 1 coming from this 2x's and that plus 1. And this is that quadratic in standard form in factor form. Right, next example. So for the next example, we have, there's no GCF here. I forgot to mention, also always check for GCF. In this case, there's no GCF. So then multiply 4 times negative 15, which is equal to negative 60. So then find the multiples of negative 60 that when you add those multiples, they add to a 4. Well, you can do a long list here. Okay, so we start with 1 times 60, and then 2 times 30, and then 3 times 3 times 20, and 4 times 15, and then next is 5 times 12, and then we do 6 times 10. I hope you see it here. 6 and 10, you can get a 4. And notice they need to multiply to a negative 60, so then that means the 10 has to be positive, right? And the 6 is negative. Okay, so let's see how this works. So I have 4x squared. I'm going to group either one of them. So I'm going to put negative 6x with the 4x squared plus 10x minus 15. And let's see if this works. So 4, there's a GCF of 2 here. So 2x, GCF of 5 on this one, right? Because 5 goes into 10 twice and 5 goes into 15 3 times. So then this is a GCF of the first group. Then this becomes x minus 3. Plus 5 times 2x, and I forgot this should be a 2 here, 2x minus 3, and this should be 2x minus 3 also. So you can see we have the same binomial. So then 2x minus 3 is a GCF in the two groups, and then put together 2x plus 5 in another parenthesis. And that's that quadratic in factor form. All right, so I'm going to do this last example on this part of the video, then I'll do the other part, examples 5, 6, and 7 on the other video, okay? So then here we have A is 1, so A equals 1, B is negative 2, and C is equal to 1. So then find multiples of A times C, which is 1 times 1, multiples of 1, that when you add them, they add to 2. But, well, 1 times 1 is 1. And notice we need that to be a negative, right? So negative 2. So in this case, so they both have to be negative. When you multiply negative times negative is positive, and then when you add them, you get a negative 2. So then this will be x squared minus 1x plus 1. So group 1, GCF of x. Group 2, GCF of negative 1. So then we have x times x minus 1 times x minus 1. Okay, so then we have x minus 1 and x minus 1. So this is x minus 1. That's GCF of the two groups. But then notice that this x is another x minus 1. So when this happens, we can just condense to a single binomial and just say that it's square. So x minus 1 square. And that's the answer to this part. That's the conclusion for this part. Okay, we'll do the other 3 examples in the next video. Thank you for watching.